This conference will now be
Good morning,
recorded.
everyone. Let us start with the session. So today, let us start with the front-end training demo session. Uh, those who have already gone through the demo video might find it to be repeating. Okay. Uh, my name is Srinivas, and I am the founder of the institute, and I handle the front-end domain-related trainings. I have close to 14 years of work experience, and around 12 years of teaching experience as well. I have been providing training since 2012. Let's first go through the agenda of today's session. We'll be starting off with discussing what all courses are starting today. And then I'll just give you a quick overview of the institute. Then we'll start with understanding the basics of electronic systems. We'll try to understand the difference between VLSI and embedded systems. What are the subdomains in VLSI? And how do you choose a specific domain in VLSI? We'll also talk about VLSI design flow. What is front-end domain? What is back-end domain? We'll also talk about the different job roles in the VLSI domain. What is the skill set required for different domains? What is the skill set required? Then how do you choose the domain? Because whatever decision you make here, that is the thing you have to work for rest of your career. Let's say you choose to do a course in physical design. For at least for next visible feature, you will be working only in physical design. So it is important that you understand the domain, what is VLSI design, and understand what is front end domain, what is back end domain, and choose a right domain right now. We'll talk about institute facilities and how you prepare for the job to get. I mean, how do you prepare to get a job? Then career in VLSI placements. And any questions? I'm the founder of the institute. I have dual degree from IT Madras. I mean, I've told you, right, 11 years experience. Okay. Let's go through the list of courses starting today. So, uh, as an institute, we offer various courses. If you go through our website, you will see that we offer courses for freshers, working professionals. Then, lot of all these courses, what you see down, mostly are meant for working professionals. In fact, for every 5 enrollments, 3 enrollments of our course are working professionals. Reason being, there are not many institutes who offer this course. Let's say if I talk of any of this protocol, PCI Express, AMBA, DDR, AMBA Chai protocol, everything. I don't see any other institute offering these courses. Even including the short, I mean, SOC courses, scripting courses, interview preparation, the projects we have been offering. In summary, we have a wide range of courses. We don't have just a course like functional verification. We don't have a course like physical design. As an institute, we have tried to set up courses across the domains. Now, having said that, we have so many fresher courses, around 6 courses. We don't want to run 6 different demo sessions, completely demo sessions. Okay. Rather, what we do is one common demo session for front end, one common demo session for back end domain. So this is the common demo session that we are doing for front end domain. Then if someone is interested in, let's say, in DFT, today at 3 o'clock, we have a DFT specific demo session. Let's say someone is interested in FPGA. FPGA is also part of a front-end domain. There will be another dedicated demo session for FPGA. We don't have to repeat everything. Let's say if you attend today's session, this session, you get an idea about what is front-end domain. Then you can specifically attend FPGA, DFT, RTL integration, any other specific courses. The same thing for backend domain also. We have a backend domain demo session tomorrow at 9:30, where it will cover physical design, the custom layout, and the synthesis STA. There are few topics. Those specific topics will be covered there. This course, what we are doing, it is meant for both freshers and experienced people also. You may say, why this course will be suitable for experienced people? Many times, people who work in the industry don't get that entire exposure. Even when you join the course, when you do the course and when you join any company, you will see that everything you learn here, you don't do there. Only part of the activity you do. Let's say you get into one entire functional verification project. You don't do the complete functional verification of the design. You will be part of a team where you will be doing coverage analysis, a team where you are developing test cases and debugging the test cases. Okay, so there will be one part of the activity you get to work, and when those people plan to change the job, they don't have that entire exposure. The working professionals I'm talking about. So that is where this course is suitable. That is where I said, right, for every 5 people, 60% of our enrollments are only working professionals only. That doesn't mean to say that our fresher courses are not good. We have a very, if I can cater to working professionals, I can offer a good courses to freshers also. Okay, so now instead of talking about it, I'll just go through the course and explain you what is the course content and how it is going to help you make the career in VLSI. So we are going to do a demo session specifically for the front-end domain courses. One course will be focusing on will be RTL design and functional verification, which is also called as front-end domain for freshers. It is the front-end domain training for freshers, design verification course, the functional verification training for freshers, ASIC verification. Whatever I say, all of them are referring to one same course. All these 5 courses refers to one same course, because sometimes people ask, I want front-end domain training. Sometimes people ask, I want design and verification domain. Sometimes people ask, I want ASIC verification training. All of them will be referring to the same thing. Of course, they have advanced aspects also. We can even talk about SOC verification. But for a fresher, it is not required. It can include some complex design verification also. Again, it is not required for a fresher. Generally, freshers are hired not because they know very complex things. They are hired because they are good with fundamentals. They are good with the basics. And once you are good with the basics, you can do the advanced things. So this is one course that is starting today. Other than that, we are starting a course on functional verification training for experienced engineers. I told you, right, sometime back, why do experienced people need to undergo the training? Because they have a gap at time. So to fill that gap, this course will be helpful. Other than that, for people who are currently pursuing their BTech, okay, they won't have time to do the entire 6-7 months of course. We have a short-term courses on Verilog and System Verilog. Other than that course on FPGA design and verification, I will be talking about what is FPGA in a short duration. Okay. Then we also are starting a course on RTL design and integration, the design for testability. So all these courses are starting today. Today's session, whatever I'm doing, is like the overview session of this. So yeah, please. This session will go from 9:30 to 12:30, and in case someone specifically wants to attend DFT, someone specifically want to attend RTL design integration FPGA, they can attend those specific demo sessions today or tomorrow. For DFT, there will be a session at 3 p.m. today, and you can request other courses. Generally, we don't have many people enrolling for FPGA, so you can talk to the admin for demo session schedule specific to these courses. First, let us start with understanding of the electron. I have just given you an overview of institute. We were started in 2012. The institute was set up with the intention of offering a good quality training at a lower cost, affordable cost, and we have been trying to do the same thing even today. Okay. And as an institute, we have been trying to cater to wider audience. I mean, not just for freshers. We have been trying to cater to working professionals as well, and we also do a lot of corporate training. I mean, reason because we have these kind of wider courses. I told you, right, the protocol courses, the projects and scripting courses. Because of that, I do a lot of corporate trainings as well. Even today, I do 3 to 4 corporate trainings in a month. That sometimes helps with our placements as well. I mean, when we are connected with the industry, when working professionals take our courses, it helps with the placements to a good extent. Okay. Now let us start off with understanding of electronic systems. Why do we want to understand electronic systems is to understand what is the hierarchy of different layers. What is VLSI? What is embedded systems? What is operating system? What is application? I mean, there are multiple things that make up a system. If you take an example of a phone, let's assume that this is a phone. There are multiple things that make up the phone. At very basic level, you have the hardware. Without hardware, you don't have anything, right? Without hardware, you cannot run an application. You cannot run any operating system. At very basic level, you have a hardware. Okay. On top of hardware, you have got something called as drivers. Drivers can also be called as firmware. Okay, that technically is called as embedded systems. Like hardware is related to VLSI, the drivers and the firmware is related to embedded systems. On top of embedded systems, you have got the operating system, which could be different operating systems, iOS, Android, Windows. There are multiple such things, right? Then on top of operating system, you have got the applications. For an electronic system to work, all these 4 layers are important. Let us try to understand an electronic system through one simple analogy. Let's try to understand the electronic system through one simple analogy. Let's take an example of a bus with a passengers. A bus is like a hardware. I mean, if there is no bus, there is no driver, there is no passenger, there is no conductor. So for anything to happen related to the bus is required. Same way, my hardware is required for my electronic system to work. Okay. So for me, the bus is like the hardware that relates to the VLSI. Who controls the bus? It's the only driver, right? It's the only driver who controls. Can I control the bus? No, right? But you can only request. You can request that stop the bus, start the bus. That you can say. So driver is like the firmware. He is the embedded system. Because that's the term. That's why the term drivers came into picture. In hardware, electronic system terminology, you hear the term drivers, right? Like whenever you purchase a new laptop, they will ask you to install the drivers, the Bluetooth drivers, the modem drivers, different drivers, USB drivers, the SD card drivers. The drivers term is coming from the same driver analogy. These drivers, what does driver do in bus analogy? He controls the bus. I mean, what all controls he has got? Accelerator, brake, clutch, handbrake, gear, 5-6 controls he has got. Through that, he controls the bus. Do you agree with that? Same way in VLSI also, in electronic system also, every design has something called as registers. 2 types of registers will be there. One is configuration registers, one is status registers. A design will have registers. What is a register at very basic level? It is a 32-bit flip-flop. If you take one flip-flop as 1 bit cell, so 32 flip-flops make up one register. More complex the design, more will be the number of registers. Simple example is you take a bus example and a aeroplane example, flight example, which has got more controls. The flight has more controls, right? If you see the cockpit in the flight, it will be very complex. So it is a more complex system. It will have more registers, more things to control. Same way in electronic system also, a design complexity is measured based on the number of controls it has got, number of registers it has got. Okay. So coming back to our analogy, the way bus driver was controlling the bus by means of accelerator, brake, clutch, handbrake, and gear. In electronic systems, the drivers are firmware. When I say drivers, when I say firmware, both of them are exactly same. These will control the hardware by programming the registers. How do they program the registers? These drivers are nothing but the assembly instructions. You are familiar with assembly instructions, right? Add, sub, multiply. There are different assembly instructions are there. Arithmetic, the shift, okay, branching instructions, jump instructions. There are different instructions are there. My drivers at very basic level consists of those instructions only. They eventually go and write and read the registers which are present in my hardware. That is how my drivers control the hardware behavior. What is meant by controlling hardware behavior? Let's understand. Assume my phone. I don't use it for 1 minute. What will happen to the screen? It will turn off. That is actually happening because of the way you have configured the behavior. Inside my mobile phone, there is a register where I would have programmed something called as 60 seconds. Then my hardware has a counter. It keeps counting. When that count reaches 60, it knows that for 60 seconds it's idle. So it turns off. So that is the role of a embed the firmware in the electronic system. Then coming back to the bus example. So what is that we were discussing about bus? We have got a driver. We have got a bus. To control the bus, you have a driver. And then who communicates with the driver? It's the conductor who communicates. So for me, conductor is like the operating system. Basically, whatever passenger wants to communicate to the driver, the conductor carries it to the driver. So what is the role of an operating system? Whatever my application wants to do, let's say I want to send a message in WhatsApp, I want to make some phone pay transfer, or I want to use Google Maps, anything I want to do, the operating system is the medium through which that communication happens between the application and the firmware. Okay, so that is how these are related. So like in going back to the bus example, as a passenger, you don't go and control the bus. You also don't want to talk to the driver directly. Most of the times you communicate with conductor communicates with driver, then driver based on what conductor has told. See, conductor will tell slow down the bus, conductor will say increase the speed, so he will accordingly control the bus controls and then gets the required behavior. Exactly the same thing happens in electronics. Now why are we understanding all these things? Because we want to have a clear picture of what is meant by hardware, what is meant by embedded system, what is meant by operating system, what is meant by applications. So as a VLSI engineers, we are responsible for development of the hardware. So we don't work on embedded system. We are only responsible for developing of the hardware. Then there are other set of people called as embedded system engineers who are responsible for development of the firmware or drivers. So let's go through with this basic understanding, let us go through the slides related to electronic system. So let's start with what goes into a mobile phone. See, if you think of a mobile phone, this is how it looks like if you open the mobile phone. It consists of different hardware components like processor subsystem, the graphics processing unit, different peripheral components like USB controller, PCI controller, DDR controller. the multimedia subsystem, camera subsystem, audio subsystem. These all things makes up the hardware of a mobile phone. As I was telling you earlier, this hardware is not alone sufficient. You cannot just take a plain hardware and start using it. You need other layers like drivers, firmware, operating system, and applications. Only then you will be able to use it. So there are it, so what all things make up a mobile phone? It's the hardware. Then there are things which we don't see, things like operating system, the Android and iOS, the firmware, the drivers, and the different applications. These all things put together is what makes up the electronic system. Now you may ask, for me to get into VLSI training, to become a VLSI engineer, do I need to know everything? You don't need to know everything. You only need to know how hardware is developed. You need to have a basic understanding of how drivers work. The basic understanding, because you interface with drivers, right? Means in simple terms, going back to the analogy, the person who is developing the bus, who is manufacturing the bus, they need to know how driver will use it, right? Can he keep a accelerator in the front of the bus and brake in the end of the bus? It won't work, right? All the controls has to be at one place which are relevant. Can he keep the passenger door at the driver next seat? No, right? It will make it inconvenient. So there are few guidelines he has to follow in such a way that it is convenient for the drivers to work with it. So that is how hardware is developed. So as a VLSI engineer, our role is to develop the hardware. So we have to know the in-depth of the hardware development process. We also need to know the basic functioning of the drivers. Again, let me repeat what is meant by a driver. Can someone tell me what do you understand from the driver? What is that consists of a driver? Driver is nothing but a assembly level instructions. If it is in my phone, which is on Snapdragon, Qualcomm Snapdragon, it will be ARM instructions. Snapdragon is a ARM based processor. It will be ARM instructions. In my laptop, which is based on Intel processor, Intel x86 processor, it will be Intel instructions. The drivers will be based on the processor that is being targeted. Anyway, let's not go to that extent. Can you tell me what does a driver actually does in a hardware? What does a driver do in the hardware? It accesses the registers which are present in the hardware, writes to those registers, reads those registers. Writing means what? Updating the register contents. Reading means what? Reading the contents. By writing and reading those contents, it controls the hardware behavior. For that, let us take one analogy, whatever we have discussed already. Your mobile phone currently has a 60 seconds display turn off. I mean, if you don't use it for 60 seconds, it goes into display turn off mode. You want to change it to 30 seconds. So to change it, what do you do? Do we open the hardware and change the value there? Do we open the mobile phone hardware and somewhere do we write 60 to 30? All right. At what level do you control? You control at the application level. You go to the settings. There will be applications specific to the display. There will be a display application. There you change number 60 to 30. Then that requirement goes to the operating system. That requirement goes to the operating system. The operating system informs it to the firmware that this behavior needs to be changed. Firmware finally writes to the registers. There will be some registers in my design. The firmware writes to that register. Now, which register it writes, what it writes, let's not get into it. Let's only understand the flow. It started off with the applications, then it went to the operating system. From operating system, it went to the firmware. The firmware specific to this requirement has something like writing to a register in such a way that number 60 changes to 30 in my hardware. So now the new counter value will be 30. It won't be 60. It simply changed that counter value from 60 to 30. Whenever that 30 seconds of idle time happens, it automatically figures out that now display needs to turn on. This is how it works. So essentially an electronic system has 4 layers. One is the hardware, which consists of things like processors, the multimedia subsystem, GPU, DDR subsystem, various things. The person who develops the hardware, what is that person is called as? He is a hardware engineer. He is called as hardware. The name is simple. Person who works on embedded system is called as embedded system engineer. Okay. Person who develops on applications is a software engineer. In hardware, person who works on developing hardware is called as hardware engineer. Hardware has subdomains. It can be a PCB engineer who works on a printed circuit board design. Okay. There can be a person who works on VLSI. That person is called as VLSI engineer. Now you may be thinking, then why we are only talking about VLSI? Why not about PCB? Tell me why we are not talking about PCB. Because there is a more demand for VLSI as of today. As of today, there is more demand for VLSI jobs compared to PCB. So there is another sector in the hardware called as PCB engineering. So there also jobs will be there. So for our convenience, we call it as VLSI engineer, but technically it is hardware engineer. The person who develops hardware is the hardware engineer. It has got subdomains. The first person who develops PCB, person who may develop a PLA arrays, programmable logic array, then person who works on VLSI, different domains. Second is what? The firmware, the drivers. Who develops firmware? He's called as embedded system engineer. You can call him as firmware engineer. The third, operating system. Android, iOS, Windows, Linux. Who develops OS? Is called as software engineer. Then you have got applications like apps in the mobile. It can be GPay, it can be maps, anything. Again, who develops? It can be a software engineer, it can be the app developers. Okay. For an electronic system to work, all these 4 layers are important. Okay, but as a VLSI engineer, as I told you earlier, you should be good with the understanding of hardware behavior. You should be good with the basics of a drivers. I mean, how do drivers communicate with the hardware? You don't need to know about this. You don't need to know about this. I've already given you the bus analogy, right? I mean, how does that bus analogy works? The bus is similar to the hardware. Driver is similar to the firmware. The conductor is similar to the operating system. The passengers are similar to the applications. I mean, reason is what? Bus is there because it wants to carry the passengers. Without passengers, there is no need of bus at all. Same way, there is no use of hardware which doesn't have any applications. I mean, if you can't use Windows, Office or anything, right? Then there is no use of such hardware. We have discussed the significance of the drivers as well. I'm going through fast because we have already discussed this concept. I don't want to make it boring. Okay. So, any specific questions as of now? Now, what is important for VLSI engineer? VLSI engineer should have a in-depth understanding of the how the hardware works. I mean, you should be very good with the entire hardware development process. A basic understanding of how firmware works with the hardware. We don't need to worry about how operating system works. We don't need to worry about what is kernel. There are many things, right? Kernel, BIOS, many things are there. We don't need to worry about all those things. So this is a very brief about an electronic system. Why did we go through this topic? Is we want to differentiate, understand What is VLSI? What is embedded system? Many times a BTech graduate, fresh graduate, can have a confusion between what is VLSI, what is embedded system. My idea was to just give that clarity. Now, which domain is more important? Which domain is better? Tell me. Both domains are equal opportunities. Both domains are good in their own respect. I will not say embedded system is bad or anything. There are a lot of opportunities in embedded system as well. Only thing is embedded system requires a different approach, mindset, I mean skill set. Like it requires good expertise with the programming, because you will be most of the time developing the applications, drivers and the firmware. It requires that kind of skill set. Okay, so there are opportunities in embedded systems as well. Let us now, since the session today is about VLSI, let's focus on the VLSI related topics. So first let us start with VLSI design styles. What is VLSI? VLSI stands for very large scale integration. What are we integrating? So what is meant by very large scale integration? You are integrating something on a large scale. Tell me, what are we integrating? When we say integrating, what are we integrating? Transistors. You take an example, a house. What is that we integrated in the house? Bricks, right? When you integrate the bricks, you got the house. Like for a big building, bricks is the basic building block. For a mobile, for any electronic chip, transistor is the basic building block. Using the same brick, you construct the room, you construct the bedroom, you construct the bathroom, everything is constructed using the same thing. In VLSI also, using the same transistor, they build everything. The processor is developed using same transistor. The GPU, graphics processing unit, is developed using the same transistor. That is called as the technology node. I mean, 7 nanometer technology FinFET, 5 nanometer technology FinFET. Okay, so coming back to our discussion, we are integrating transistors on a very large scale. Now going back to the house example, for a big building, like a, let's say I want to build an engineering college which has got too many floors, let's say 10 floors, it will require a lot of bricks. I want to construct a small room, it will require very few bricks. So depending upon how many things you want to integrate, it is called as small scale integration, medium scale integration, or large scale integration. So we are integrating transistors. Since we are integrating billions of transistors, it is called as very large scale. In VLSI, there are two styles of developing the chips are there. In VLSI, when you develop the chips in VLSI mode, there are two styles are there. One is called as ASIC. Other is called as FPGA. ASIC stands for application specific integrated circuit. What is mean by application specific? You understand term integrated circuit, right? Any assembly of transistors makes an integrated circuit. You assemble 10 transistors, it's an integrated circuit. Integrated means what? Interconnected circuit, right? Then what is meant by application specific? When we say the term application specific, what do we mean by it? It means that integrated circuit is developed specific to an application. Let's say I have developed something to work like a remote control. This is a projector remote control. It can only be used as a projector remote control. I cannot use it as a TV remote control. It won't work. Okay. So then some of the if I develop a chip to work only like a projector remote control, it will only work like a projector remote control. It is that technology is called as ASIC, because I cannot use this hardware which is inside this device for anything else other than remote control. Then it becomes ASIC. You may say everything is developed like that only, right? I mean, then actually speaking, there is another category of chip development style called as FPGA, where you have got a generic array. You have got a generic array of gates, this is called as a FPGA board. It's called as what? FPGA board. You would have heard of Xilinx Spartan boards, Altera boards, different boards. What those boards have is they have got an array of gates. See why it's called as array? If this one line is there, if I write multiple such lines, these are called as arrays. You know arrays from the basic programming languages, right? Like in arrays in C language. The same terminology is being used here. Array means replication of the things multiple times. You have got an array of gates. Now, each thing can be programmed for your requirement. Do you want it to behave like an AND gate? Do you want to behave it like a OR gate, NAND gate? You can program it. So in FPGA, what happens is the same board can be programmed like to work like a mobile phone, can be programmed to work like a remote control, can be programmed to work like something, some other electronics. See, now it is not application specific, right? You can use the same board for different requirements. That kind of technology is called as FPGA technology. Okay. As of now, if you see, which one looks better? FPGA looks better, right? Because it offers flexibility, where you are able to use the same board for different requirements. You are able to use the same board to work like mobile, same board to work like a remote, or same board to work like a some router, for example, as long as that board has the resources. But as we go forward, we will understand that ASIC is the preferred style. Even though FPGA offers more flexibility, industry prefers ASIC style. Only one of the primary reasons for that is the cost. Cost of developing a ASIC chip is 30% of FPGA. Much cheaper than FPGA. I mean, 30% is just a number. It can be any number, 30%, 20%, 40%. There's no such exact number. But ASIC, when you manufacture in bulk, bulk means what? Lakhs or millions. ASIC will be cheaper to develop. So that is the reason why industry will prefer ASIC style of developing the chips. With this understanding, let us proceed further. So what does ASIC stand for? Application specific integrators. What does FPGA stand for? Field programmable gate array. In the field programmable gate array, same FPGA board, the same board, let's say Spartan 6, you can configure it for specific hardware. Then you can reprogram it to behave like a different hardware. So same board can be programmed to behave like different applications. Okay. As you see, which one looks better? I said FPGA looks better, right? I mean, FPGA offers more flexibility. But as I said, industry prefers ASIC over FPGA due to the low cost of manufacturing. Then the next question comes: if ASIC is cheaper, then why don't we do everything in ASIC only? What is the question? If ASIC is cheaper, why don't we do everything in ASIC only? Just remove FPGA from the market and do everything in ASIC. So each of them has their own importance. ASIC has some advantages, some drawbacks. FPGA also has some advantages and some drawbacks, disadvantages. So we will discuss both of them. So when a company, let's say I set up a company, I want to develop a product. I want to develop a remote control. Actually, that's my requirement. So I will make some assessments. I mean, analysis. What is my requirement? How many remote controls do I want to manufacture? So based on some parameters, I will decide whether to go with ASIC, whether to go with FPGA. In both the styles, either I use ASIC or use FPGA, I will still be able to develop the same remote control. But I look at different options. How quickly do I want to bring out the hardware? What should be the cost? There are multiple such factors that as a company I decide before I choose it as a card. Let us talk about ASIC versus FPGA. So this diagram what you see down explains the cost of ASIC versus cost of FPGA. Can you tell me what is the x-axis is indicating here? What is x-axis is indicating? Volume. How many units I want to manufacture? Like how many remote controls I want to manufacture in my example. What is the y-axis indicating? Cost. When to manufacture, let's say 100 remote controls, how much it will cost me? To manufacture same 1 lakh remote controls, how much it will cost me? That is what is the y-axis is giving. If you see at this point, how many units is it referring to? 0 units. Let's say I want to manufacture 0 units, but I want to set up the flow. FPGA will have a small cost because before you come out with the product, you need to have a team of people, right? You need a team who will work on the FPGA board. Whereas ASIC cost will be very high. ASIC cost is this much. FPGA only cost. So which one has a higher initial investment? ASIC has initial higher investment. But as you increase the number of units you want to manufacture, ASIC curve is flat like this. FPGA is more slanted. So there is a point comes here. Till this point, which one is cheaper? FPGA is cheaper. How do I say that? You draw like this. This is the FPGA cost. Let's say to manufacture, let's say here 250 units. Assume this number is 250. Assume. What is that? I want to manufacture 250 remote controls. For me, FPGA will cost me this much. ASIC will cost me this much. Like whatever that line. Now, let's say I want to manufacture 2000 units. ASIC will cost me this much. FPGA will cost me this much. Tell me which one is cheaper? ASIC is cheaper. So there is this cutoff point, break-even point, where after that ASIC is cheaper compared to FPGA. So this is one of the important factors I'll consider before I choose whether to go with ASIC or FPGA. For example, I want to manufacture 1 lakh remote controls because I saw that there is a lot of demand for remote controls. Every house will purchase it. So I decide that I want to manufacture 1 lakh remote controls. So I will do that calculation. For me, if I do with ASIC, what will be my total cost? If I do with FPGA for 1 lakh, what will be my total cost? And again, there are some other factors which we'll discuss. Based on that, I will decide that okay, let me go with ASIC style. Other is what? Just putting together all this thing what we discussed. Cost of ASIC design flow will be multiple $1 million. Initially, we have to start. The initial investment will be multiple $1 million. Since we need to start everything from scratch. Once the flow is working, per chip cost will be less. See, once this is done, the gap is very less. I mean, it is not a major cost. Whereas in FPGA, cost is very high. For every chip you have to manufacture, the cost is very high. In FPGA, the initial investment is less since hardware is readily available. See, for you, you don't have to manufacture Spartan board. Do you manufacture Xilinx board? You just go and purchase the board, right? Maybe 7,000, 10,000, less than few, it will cost in few thousands or maybe lakhs based on how complex is the board. Then using that board, you implement your circuit. So, but per chip manufacturing cost will be more. So any VLSI chip, any chip can be developed either using ASIC or FPGA based flow. Decision is based on the overall cost. Which one is more cost effective for me? And the ASIC based flow, let's say just for comparative analysis, ASIC based chip will cost, let's say, $15. FPGA based chip will cost $50. Okay. So companies which manufacture products for bulk uses, they will go with ASIC production. Like Qualcomm manufactures the mobile phone chips. What do they go with? Do they go with ASIC or FPGA? ASIC. Let's say Boeing is there. What is Boeing does? Manufacture the aeroplanes, right? They will manufacture millions of aeroplanes or hundreds of aeroplanes. Hundreds only, right? Hundreds of aeroplanes only they'll manufacture. So there, does it make sense to go with ASIC or FPGA? FPGA. So Boeing will work in FPGA style. Again, Cisco, they want to manufacture some millions of routers, for example. They may go with ASIC. So depending upon, they will choose whether to go with ASIC or FPGA based on those things. Again, NVIDIA is there. NVIDIA now is working on, let's say, some GPU chips or artificial intelligence chips. They will sell in millions. They will go with ASIC. So that is how the company makes a decision whether to go with ASIC or FPGA. Which company go for FPGA based production? Companies which manufacture for limited applications. They don't sell in bulk. Hardware used in flight sells in thousands. So now we have discussed what is the difference between ASIC and FPGA. Let us try to understand the advantages of ASIC over FPGA. First advantage of ASIC is it is cheaper. I mean, the cost of manufacturing of each chip is cheaper. Second is it is consumes less die area, hence it is cheaper. I mean, what happens in ASIC is you customize your requirement. So because when you do the ASIC flow, you have a lot of flexibility in doing the physical design. You do the physical design manually. You place a block here, you place a block here, you place a block here, like this. You can customize the area and reduce the overall area of the chip. In FPGA, you don't have that flexibility. In FPGA, you have a board, on that you are trying to place the things. Now, tell me, where can you reduce the area? ASIC or FPGA? ASIC. Because in FPGA, you already have a board. You have to plan according to the board. You have to plan your designing according to the board. In ASIC, you don't have anything. You first plan it, then you manufacture it. So ASIC will consume less die area, hence it is cheaper. Provides flexibility to customize the design feature. You can customize because again you are starting from a plain thing where you don't have anything. You can customize the way you want. Power efficient. You can also implement a circuit which is power efficient. Now ASIC can work at higher frequencies compared to FPGA, hence give better performance. Something which works at higher performance frequencies gives a better performance. Now, on the other side, what are the advantages of FPGA over ASIC? If the chip has bug, let's say I developed this remote control, I have manufactured 10,000, but speed volume I am not able to increase. The volume button doesn't work in all the remote controls. So if it is ASIC and the problem is related to hardware, I have to throw out all these remote controls and I have to start the entire process. In FPGA, advantage is once you manufacture one remote control, you can only manufacture one remote controller. You can verify this remote control. If it works fine, then you can manufacture remaining 10,000 remote. So in FPGA, you have an option to fix the bugs easily. There is some bug, you can recover. I mean, you can update your design, you can re-implement on the FPGA board. But in ASIC, you don't have such flexibility. If a chip has a bug which is detected after manufacturing, FPGA style won't incur big cost. In FPGA, your cost is only one board. If this board is not working, you throw off this board. You take a new board and implement your logic with the updated, corrected. In ASIC, it won't be like that. You manufacture 10,000, all 10,000 will go. We don't have to implement the entire flow again in FPGA. Bug can be fixed in the other FPGA board. We don't need to start from scratch. In ASIC, if there is a bug, we need to do the entire flow again. Second advantage is FPGA flow is quick because you have the board readily available. If ASIC takes 6 months, FPGA can be finished in 3 to 4 months. Since we don't start from scratch, the board is readily available. It takes less time to develop FPGA flow compared to ASIC. In fact, FPGA is used at one stage of ASIC design. See, even in ASIC flow, people use FPGA because once you develop your RTL code, Verilog code, to verify that, we use a basic FPGA board. Once it works, then you go to ASIC manufacturing. That is called as FPGA prototyping. That concept is called as FPGA prototyping. What is FPGA prototyping? It is used to check the ASIC behavior before it is manufactured. Before manufacturing the ASIC, you verify your design behavior using a FPGA. The next thing is FPGA prototyping. What is meant by FPGA prototyping? Implement ASIC logic onto the FPGA board and check the behavior. We can figure out any issues in the design before going for ASIC production. What is meant by production? Manufacturing is called as production. So ASIC versus FPGA. I think I have already discussed this concept. Next, talking about VLSI design flow, where does it differ between ASIC and FPGA? Let us understand. In VLSI, going forward, you will see that majorly there are two domains are there: front-end domain and back-end domain. In both FPGA and ASIC, front-end domain is similar. The VLSI front-end domain flow is similar in both ASIC and FPGA. In both the cases, user need to understand the design specification, implement the design using Verilog or VHDL, then do the functional verification of the design using SV and UVM. Okay. In summary, what I was telling is my VLSI flow has two steps. One is the front-end domain, one is the back-end domain. This is the entire flow. Initial part of it, which is front-end domain, is similar for both ASIC and FPGA. For both ASIC and FPGA, the front-end domain flow is very similar. The way you read the specification, the way you implement the RTL code, the way you verify the design, it is similar in both of them. The actual difference comes in the back-end domain. Where do ASIC and FPGA differ? Majorly, they differ in the back-end domain flow. The flow starting from physical design to custom layout, there they differ. Because in ASIC, you can customize completely. You don't have any chip. You plan where to keep the processor subsystem, where to keep multimedia subsystem, where to keep interconnect, where to keep the driver, controllers, everything you decide. In FPGA, you don't have any FPGA, you have a board, on that you try to place your things and try to do the timing closure. The way we do floor planning, placement, power planning, CTS, routing, IR drop analysis, they will be completely different between both. All these steps different. So this is about the difference between ASIC and FPGA. Around 85% of the companies, 80 to 85% of the companies work in ASIC. Another 15% of the companies, 15 to 20% will work into FPGA based. There are job opportunities in both the domains. It's not like only ASIC has jobs, only no jobs in FPGA. Both will have the opportunities. Let us now talk about ASIC design flow. We'll discuss about this and we'll go for a breakup. So any questions so far? So we have discussed two aspects so far. First, we have understood what is an electronic system, what all things makes up electronic system, starting from hardware, the firmware, operating system, and the applications, and how they interface with each other. Then we have understood what is VLSI, what are the two different styles of VLSI design. One is ASIC, one is FPGA. Okay. Since most of you are getting into front-end domain, for you there is not much difference between ASIC and FPGA as long as you work in front-end domain. But when if at all you want to work in FPGA back-end domain, then you need to learn a little bit of what is floor plan, what is timing analysis. So now let's move on to the third part of the today's session, that is ASIC design flow. Before we go to ASIC design flow, what is about ASIC design flow is finally what is the outcome of ASIC design flow? Can you tell me? It is a chip, a manufactured chip is the outcome. Then why you are going through this ASIC design flow? You want to manufacture a chip that goes into a remote control, that goes into your mobile phone, or that goes into your laptop. This is very similar to house construction. Let's say you want to construct a house. Okay. Where do you start your house construction from? Let's say you want to construct a house. Where does your thinking start from? Requirements. What do you require in the house? Right? Without that, do you directly start with the foundation and everything? All right. First, you start with what is my requirements of the house. Then whom do you go to? Once you have the requirements, whom will you go to? There will be an architect, right? House architect will be there. What he will give you? He will give you the plans, right? The floor plan. He will give you what else? The electrical plan, plumbing plan, everything he will give you. With that, whom do you go to next? There will be some contractor or a mestri to whom he will give all those inputs. Whatever you got from the architect, you give it to the next stage. What the contractor or mestri will do? He will give you the basic structure without any electrical, without any plumbing, without any carpentry, nothing. Then you go to different stages. Once carpenter will do the work, once the salesperson, once the plumbing. Finally, your house is ready. Now, first question: does one person do entire work? Now, can you ask a carpenter to do the plumbing work? All right. Each of them has their own expertise. In this entire flow, how many people are roughly involved? How many types of people are involved? Like carpentry is one category. Plumbing is another category. So how many categories? Almost 10 to 15 categories. See, if I want to construct a simple room, do I need interior designer? No. But if I want to have a bungalow kind of thing, then I'll go for interior designer. So accordingly, number of people involved will also change. Sometimes I may need only 5 people if the design is simple, house is simple. If the house is very complex, I need more people. Same is with the ASIC also. To manufacture a chip, if the chip is simple, few people, 2-3 people can finish the chip, entire thing. Same person can do painting, same person do plumbing, if it is simple. But if it gets more complex, you need a dedicated team, dedicated set of people for each activity. So like we discussed earlier, one person cannot do other person work. In VLSI also, the role is defined based on what you do. The person who do physical design is called as physical design engineer. The person who do RTL design is called as RTL design engineer. Person who does DFT is called as DFT engineer. DFT engineer cannot do physical design. Should not do because he doesn't know physical design. A front-end verification engineer should not do physical design. Again, he doesn't know what is physical. So every person has a defined set of roles which you have to learn. So that is what we do in the institute. We try to help you gain expertise in one specific domain. We help you gain expertise in one specific domain. There are many places which I have seen where they try to teach something of everything. In one resume I had got, it was supposed to be physical design and physical design resume. I mean, through a known person, he said need job support. I saw the resume. It was supposed to be physical design engineer. Then I saw some router project, router verification set. I was looking where is the physical design project. I mean, what technology node, what tools he has used. But then I was seeing some router verification models. So I was confused whether it's a physical design resume, whether it's a functional verification resume. So we don't do that confusion. The first thing for you to get a job is not the institute, okay? It's not the certificate, it's the expertise with one specific domain. When you go to the job, they won't ask you, do you know the entire ASIC flow? Okay. They won't ask you, can you do 4 different activities as a one person? They won't ask you because they don't expect you to do that. They want you to be good with one specific domain. So that is what we try to do. We try to spend a lot of time on one domain only. Okay, and we encourage you to gain expertise in one domain. So now, with this understanding, let us go into the ASIC design. As I told you, the house construction flow, there are multiple requirements, multiple things. What is that you need to learn from this is that output of a previous stage becomes input to the next stage. Whatever is the output of previous stage, let's say you went to architect. Architect gave you some plans. That becomes input to the next person. Whatever that Mestri or contractor gives you, the building, that becomes input to the next person. So they are all interrelated. If they are interrelated, what does it mean? I cannot do plumbing work before architect work. I cannot do carpentry work before construction. So there is an order that has to be followed. There is a specific order that has to be followed. Even in chip design also, chip design is very similar to this. Very similar to this. Okay. There also we have to follow the order. First they do RTL. There also we list on the requirements. Before we get into it, the ASIC design flow can be understood as 15 steps divided into 2 categories, 2 major categories. First category is called as front-end domain. The other category is called as back-end domain. Front-end domain, this is where the thing starts. This is where the thing starts from. How do I correlate it with my house example? Till you construct the building is one step. Once you construct the building, a lot of things are there, right? Carpentry work, tiles work, plumbing work. That itself is a major thing. That is like the backend. I mean, don't literally take it. Don't literally think where is carpentry, where is plumbing. I'm just telling you that the way you can divide your house construction into 2 stages. One where you come till construction stage, one after that. In VLSI also there are one point where everything before that is called as front end domain. Everything after that is called as back end. So where does the front end domain start with? It starts with the design requirements. Like what do you want out of the mobile phone? Let's say my remote control. What switches I want? What controls I want? Okay. Do I want it to be a wired one, remote? Everything, right? There are multiple things I want to. What type of remote I want to have? UART remote or what protocol to use to communicate with my projector? All that I will decide. Once it is decided, I go to architect. He will give me what? Architecture and the plan. Then whom do you go? Like in house construction, you went to a masonry contractor. In our VLSI, we have something called as RTL Design Engineer. RTL stands for Register Transfer Level. So we have a team called as Design Team. What do the design team will do is they will take these things, implement that in Verilog code. They will develop a Verilog code to implement this behavior. It is similar to taking something like bubble sort algorithm. You have algorithm, implement it using C language, right? You take a, how do you do bubble sort? The same logic you can write in C language, right? Where once you give the numbers, it will automatically do the sorting. Something similar to that. You have some data document that you implement like a Verilog language. That is called as RTL design. Now, when I develop bubble sort code, C program, do I need to test it or should I not test it? I should test it, right? Because I may have done some mistakes in the sorting algorithm. So for that, what do? We provide some inputs and do the testing. Here also there will be something called as functional verification, where we verify the functionality of whatever code has been developed. In between, you see one stage called as integration. What is integration? Is we don't develop everything, the whole laptop. If I take the entire laptop, this is not developed by one person. Different blocks. This is developed by person A. This is developed by person B. This is done by person C. All these are integrated by person D. How many people are involved here? 4. A, B, C is called as design engineer. D is called as integration. Simple, right? Very simple terminology. The person who develops a design is called as design engineer. Person who integrates things are called as integration. Person who verifies whether this is working fine or not is called as functional verification. Let us now understand what is meant by functional verification through some simple example. Let's say it has got, I am talking about one design called as Ethernet MAC. What is the name of the design? Ethernet MAC. This is the Ethernet MAC that goes into my chips. But it's a very simple version, simple one, not a gigabit Ethernet. Okay. This Ethernet block, what you see goes into your mobile phone or anything, right? In laptop also Ethernet port is there. Wherever Ethernet port is there, this port behavior will be there. Before it became an Ethernet chip, it was actually this Verilog files. Before it became a chip, that is these Verilog files is what was converted into chip. This Verilog files has the behavior of an Ethernet protocol. Like how do you frame an Ethernet packet? How do you do collision detection? How do you do full duplex transmission, half duplex transmission? I don't want to introduce too many complex terms here. In simple terms, how Ethernet behaves, how Ethernet, if we drive the information, everything is what is implemented in these files. So if I have to talk about what is meant by functional verification is, if I take this design, what is the name of this design? Ethernet receive control. This block is responsible for controlling the receive. I mean, whatever data my laptop receives, it controls, it decides how to handle that. My laptop is also receiving some data. Actually, from Ethernet port, my laptop is receiving some data into lap here. My Ethernet port will decide how to handle that. If I take such a design, there is a possibility that, see, this consists of how many lines? Around 430 lines. How many lines are there in this one file? 430 lines are there. Similar to that, I have almost 38 files are there. 30 or 38, whatever, different files are there. If I remove this, around 32 files are there. Somewhere, what is this operator? AND, right? This is called as bitwise ANDing operator. So this is bitwise ANDing operator. Okay. By mistake, it has been marked as bitwise OR. The person who was developing the code, what is that person? RTL engineer. Tell me, who is the person who develops the Verilog code? It is called as design engineer. Ideally, the requirement is to use a bitwise AND, but he has used bitwise OR. Now I give you this code. As an RTL engineer, I have developed and I have given you this code. Do you agree there is a mistake? But when you get the code, you don't know whether there is a mistake, whether it's working fine. Because now that I told you that there is a mistake, you know there is a mistake. Now tell me, where is the mistake? Which line number has a mistake? I go through the entire code, tell me which line number has a mistake. You cannot tell just like that. You cannot go through each line. Can you tell me, is there a mistake here? Is there a mistake here? Is there a mistake here? You cannot tell anything like that. So as of now, there is a mistake here. Because I know I did a change in line number 429, I know that. But when someone gives you the code, they will not tell you that this code has a mistake on line number 429, right? You are supposed to figure it out. That you cannot do by looking at the lines. Okay. So the process of identifying such mistakes is called as functional verification. What is functional verification? Process of verifying the design bugs. This is a bug which was supposed to be an AND gate and logic. It has implemented as a OR logic. So that is a mistake which we cannot figure out by looking at the line. So we have to do something called as verification. There what we do is we take a design. This is the design code. Whatever design we are verifying, you develop something called as reference model. Who has given you the design? Design team has given you. You develop your own model called as reference model. This is called as what? Reference model. You apply input here. The same input is applied here. Whatever output comes, you compare both of them. If it matches, then it is good. Otherwise, there is something wrong. To put it in simple terms, you have a design. Who has provided you the design? Design team has provided you. Who develops reference model? You develop. You as a verification engineer, and let's say I am a verification engineer, I will develop my own reference model. The way I think design should behave. Based on my understanding of the design, I develop my reference model. Then what will I do? I will apply different types of inputs here. I will apply different types of inputs. The same inputs are given to reference model also. Based on how these outputs behave, comparison, whether it matches or mismatches, I tell whether it is working fine or not. Then I will go and debug. The failure, comparison failure won't tell that there is a mistake here. I have to go through some paths and then figure out that there is a mistake. That is the complexity involved in the role of a verification. Okay. You may say why it is not such a big problem in software, C program and other things. In C program, it's more like a English. This is not very much English. So these signals are involved. Signals are involved. In software, what happens is it's more like an algorithm, English only, plain English. You know that something wrong happens, you can actually pinpoint this is where the bug will be in a software. Let's say in a banking application, some deposit is not happening properly. Will you go and check the loan application? Right? You will check at the point where the deposit happens into the account. Here the problem is you need to understand what is this signal, you need to understand what is this signal, you need to understand what is this signal. Only then you can debug, you can analyze what is happening here, why something went wrong here. So that is the expertise a verification engineer requires. Okay. So going forward, after 1 year or 2 years when you work into the industry, you will realize that verification engineer work is more to do with the debugging than coding. See, a lot of times I would have told, my team would have told that verification means it needs a lot of programming. It needs programming expertise. More than programming expertise, it's this kind of debugging expertise is what is more important here. I mean, how can you develop the things where you can figure out the mistakes easily? That kind of skill set is what is most important for a verification. Of course, coding is required because you need to understand what is this code, right? Sometimes you need to develop the program. Sometimes you need to understand the code. But most important of all that is debugging, ability to figure out the mistakes. Okay, let's say someone has given me wrong code only. And I tell, after all verification, I tell this code is working fine. Is it correct? What will happen if this bug is there? That will actually go into my chip. That will go into my laptop. Then will laptop work fine? No, it will work for many things, but it will not work for few things. Will you buy such a laptop? Let's say you have a laptop which works 99% of the times, but it doesn't work 1% of the time. Will you buy such laptop? That is the problem. This is going to be. It is not going to make it fail every time. That one small thing that happened, it's not going to make it fail every time. It will fail some of the times. Some of the times it will work fine. But look at the overall thing, it's a bug, it's a problem. So the role of a verification engineer is to catch that. I mean, you may think, is it the only mistakes that can happen? There can be many mistakes. The entire logic itself could be wrong. These values could be wrong. This addition could be wrong. Okay, the entire logic itself could be implemented wrongly. A completely wrong analysis people have done. So a verification engineer's responsibility is to figure out such mistakes and report. Whom he will report to? The design engineer. He will tell to the design engineer that you have done this mistake. What design engineer will do again? He will fix that mistake and he will again give you. That process goes on till the entire design is fixed for the issues. This is how. This is the role of a verification engineer. So what I wanted to tell you is that verification engineer is not just about programming. Programming and coding is one part of the job. After a few years, when you actually get into the industry, it is more to do with the debugging expertise, understanding the design, understanding the test page, figuring out where the mistakes are there, how to catch them, how to develop, I mean, what kind of scenario you should apply so that this bug can be detected. You understood? So what is actually what you need to learn over 6 to 8 months of time? I have tried to explain in 5 minutes. So you may not have understood everything. So don't worry if you didn't understood about what is functional verification, what is that AND symbol, what is that OR symbol. With time, with patience, with learn. So that is, now do you understand what is meant by RTL verification, functional verification? Then we do something called as design for testability at the Verilog level. Design for testability at the Verilog RTL level. Then you have got backend domain. Once it is done, so here what is there? You have got a Verilog code which was implemented that has been verified. Can you use it as an electronic product? Can I use Verilog code? Let's say I want to buy a mobile phone. Can I buy a Verilog code and use it as a mobile phone? So right, I cannot do that. You need a chip. So the process of converting this RTL design into a chip is what is called as backend. Take the RTL code, Verilog code, convert it into a chip. That entire process is what we call as the backend. Now tell me, does software has a backend domain? It doesn't have. Why? Because in software, they don't manufacture. You go to Infosys, they don't manufacture a chip. They develop software application. They develop software application that can be installed and used. Their work stops here only. Their work stops with the code only. They don't have to convert the code into a chip. Whereas in VLSI, we have to convert the code into a chip. That is the additional process that we follow in the VLSI. So what is the backend domain starts with? Synthesis. What is synthesis? The process of converting our Verilog code into gate level code. Whatever Verilog you have written, it is converted into AND gate, OR gate, NAND gate, NOR gate kind of format. That process is called as synthesis. From here, the backend domain starts. Once it is done, we do design for testability at the gate level. We do physical design. We do static timing analysis. We do custom layout. We do physical verification. Then, once all this is done, so entire flow is implemented. We extract a file called as GDS2 extraction. Let me tell you what is meant by GDS2 extraction. What is GDS2 file? I will give you one analogy. See, there is a movie, you want to watch a movie. Okay, what will be the general format of a movie file? MP4 or WMV. There will be some 2-3 formats will be there, right? MP4 is mostly used one. Okay. So that movie went through various stages. The production stage, direction, screenplay, a lot of things are there, right? Recording, it went through various stages. Finally, it came out as a MP4. The same thing is the GDS2 in our VLSI. It went through various stages. Finally, the chip need to be manufactured, right? That file which is used for manufacturing purpose is the GDS2. It stands for Graphic Design System. This file basically is like a 3-dimensional description, how the silicon will be, wafer should be there, where the metal should be deposited, where the oxide should be deposited, etching should be done, where oxide should be deposited, where the doping should be done, where the lithography should be done. That is what this file will tell. How much doping to do, how much metal to deposit, what is the thickness of the metal to deposit. That is what this file will tell. These inputs, the foundry will take, foundry like TSMC will take, and then they will manufacture the chips. Once these chips are manufactured, how the chip manufacturing will happen? In ASIC, it will be like a silicon wafer, like a metal plate. They manufacture chips like arrays. So this is one chip. This another chip. This is another chip. This another chip. Like that, they will manufacture different chips. They manufacture the different chips. Now there is a possibility that during manufacturing some mistakes can happen, some defects can arise. It may so happen that it may be working fine, it is not working due to manufacturing defects. The process of identifying which chip is good, which chip is bad is called as post-silicon validation. Post-silicon means what? Post means what? After. Once the silicon has come out, when you verify it is called as post-silicon validation. So during post-silicon validation, they will figure out, let's say out of 100 chips, how many chips are there in this? Let's say 100. Out of 100, 90 chips are good, 10 are bad. This 90 is called as yield. 90% is the yield. So your manufacturing happened with the 90% yield. So this is all what is involved. GDS2 file goes for fabrication. After that you do post silicon validation. Then it goes for packaging. What is meant by packaging? Putting everything into like a mobile phone, do the packaging and they will sell. So this is all what is involved in the entire process. These steps are called as front-end domain. These steps are called as. So let us take a break now. What is the time now?
This conference will now be recorded.
Hello everyone. Let us resume the session. So before the break, we were discussing about ASIC design flow. We have understood that ASIC design flow is about manufacturing of the chips. Simple terms. So that entire process can be divided into two categories. One is front-end domain, one is back-end domain. Okay. Till whatever we have understood so far, based on that, we will see that this is more to do with the programming, understanding of the design architecture, debug expertise. Front-end domain is more to do with programming, having the debugging expertise. I mean, it's not like today you should come with that expertise. I mean, you should not tell, I'm joining this course, should I know what is debugging, how to do it, debug something? No need. You should have that willingness to learn that kind of work and the ability to understand the design. That is the expertise required for front-end. What is not required in front-end domain? What is not required? You don't need to know any semiconductors. You don't need to know what is fabrication. You don't need to know any current voltage theorems, circuit theory. Nothing is required because it is not involved at the front-end domain. If you ask me, I'm getting into front-end domain. Should I know what is FinFET technology? What is short channel effect? Okay, no need of that. Because at front-end domain, you don't need to work at semiconductors, transistor. Let me again repeat, what is the skill set required for front-end domain? First thing is good with programming. Again, you don't need to come good with programming. I mean, that willingness to learn the program. It is still okay if you don't know C language, you don't know Verilog language, also is fine. But that willingness should be there that, okay, I want to learn programming. I can learn programming. What is second expertise required? Ability to debug the issues. Some issue comes, how do you debug the things? Third, what? Ability to understand the design. Given a design document, let's say there will be some documents. How do you read the document? I mean, show you some. This is the document I am talking about. I mean, reading this document, understanding the each and every paragraph, understanding the description of this document, understanding this diagram. You see, there are, how do you understand this diagram? How quickly you can understand what is happening in this diagram? This is the kind of skill set that you require in front end. Going to back end domain, it's a different skill set that you require. In back end domain, you don't need any programming expertise. You should be good at basics of semiconductors, like what is FinFET, what is short-term effect, what is IC fabrication, the basics of circuit theory, like what is current, what is voltage, how the voltage voltage and resistance circuit works. Okay, and when capacitor comes into picture, how does it behave? RC circuit analysis. So these kind of things is the fundamental things. Then you need to learn the flow, like how the physical design flow is implemented, how to use the softwares to implement the flow. In summary, this requires a different type of exposure. This requires a different type of exposure. Let me again repeat. In backend domain, it's more about working at the semiconductor and transistor level, right? So you should be knowing those fundamental things. And a lot of things in backend you implement using a tool. You don't do manually. So you should be good at using the softwares to do the things. Simple analogy is like spreadsheet is there, XLS is there, Windows spreadsheet is there, right? People can use it in different ways. How efficiently you can use is what makes you good with spreadsheet, right? Like how do you create the tables? How do you increase the font size? How do you do the filtering with key shortcuts? Something like that. Such an expertise you should develop with the physical design tools as well. I'm not telling that to get into physical design you should know spreadsheet. I'm just giving you an analogy. So have you got the idea? What is front end domain? What is back end domain? Let us talk about, since today's session is about front end domain, let's only focus on front end domain related things. Front end domain flow is similar to software flow. What is the skill set of a software engineer? C, C++ and Java. They should be good at reading software specifications. There will be software specification which tells how the software is behaving. Okay. Then develop algorithms and implement these using these languages. Should have good programming skills. They should have good programming skills. Similarly, a VLSI front-end domain engineer should be good at Verilog, SVUVM. Verilog is similar to C language. SV, System Verilog, is similar to C++. UVM is similar to Java. A lot of similarities are there. What is similarity here means? C++ is a object-oriented programming language. Similarly, System Verilog is also object-oriented programming. Java is what? Built on top of C++, right? It works on top of, same way UVM works on top of system. Lot of similarities. A VLSI front-end domain engineer should be good with programming or have inclination to learn programming. Reading hardware design specification, understand the design functionality. Implement the requirement using various protocols. Like protocols like USB, PCI Express, DDR, AMBA, SPA, they should be good at this kind of. So in summary, this is the kind of skill set you require if you want to get into front-end. One is languages, programming inclination, reading the specification, learn some protocols. 4 aspects. One more thing I missed, very important thing, the debug expertise, ability to debug the issues. Now, where does VLSI differ from software? I told you software doesn't have a backend domain. VLSI has a. That is the only thing I'm explaining. This front end, since I don't explain what is front end domain, what is back end domain, I explain. Now let us talk about different job roles in the VLSI. Based on what is our person does, we just call him that specific engineer. Person who does design requirements, who collects the design requirements is the marketing team. Person who works on architecture is the design architect, also called as chip architect. It's called as chip architect. Person who does RTL coding is called as RTL design engineer. The person who does integration is called as integration engineer. Functional verification is called as functional verification engineer. Person who works on DFT at RTL level is called as DFT engineer. Like that, specific to what they do, they are given specific designation. Only one thing you need to understand is once you get into, let's say, functional verification, you will not do backend domain related activities. Most of the career, let's say I worked throughout my career, I was only doing functional verification. Only doing functional verification. Let's say I worked 14 years. All the time I worked only in functional verification. I never did any physical design, I never did any DFT, anything. Because I am not expected to do all. Where are the job opportunities? So you will understand that lot of people work into this domain. What are the two domains? Functional verification and physical domain. That is where you see lot of job requirements. Lot of job requirements will be there in functional verification and physical. Now, there, let me show you the typical team distribution. Let's say if a team size is of around 50 people. It's a mobile project, mobile SOC project. In the team, there are 50 people are required. Around 25 to 30 people will be required in front end. Out of that, there will be only one person who will be the architect. You want to construct a house. Do you need many architects? One is sufficient. Design team will be 4 to 6 people. Verification team will be around 15 to 20 people. Which team requires more people here? Because you need to verify it. See, now you may say why design is less, why verification is more. Reason is design is the companies buy the things from other companies called as IPs, intellectual property, and they reuse it. Let's say I want to develop my mobile phone. I don't develop everything from scratch. I go to Synopsys, I'll buy DDR controller. I go to ARM company, I'll buy their ARM processors. So different companies I'll go and I'll just buy the things. Mostly what my team will do is they'll do the integration. Most of the time, the team will only do integration. That is what this design team will do a lot of times. Understood why we don't need many people there? Because a lot of times it's the you purchase from other companies and integrate. But even when you integrate, you still have to do the verification, right? So you have purchased DDR controller from Synopsys. I still have to verify whether the DDR controller works fine or not. For that, you need verification. Because you cannot afford to have a mistake. I mean, let's say out of this mobile phone is a complex thing. In this, let's say Keyboard is a small feature. If it doesn't work, then there is no use of mobile. You won't be able to use it. Same way, every small feature is also important. Every small feature is also important. So everything need to be verified. Hence, you need more people here. Backend domain. You need around 20 to 25 people. Then remaining people in backend domain. There also, where do you require more people? Other teams like DFT, STA, layout will require lesser people. Generally, what happens is the teams where less people are required, mostly they will go with experienced people. Many times, companies where teams where they require bulk, they will go with a mix. Out of this 15 to 20, 10 will be experienced, around 5 to 10 will be freshers. Here, if you already require only one person, will you go with fresher or experienced? So when you have less requirements, they'll go with experience. Now you may say, they want only experience, where do they get it from? It has to start as a fresher. So they will start as a physical design engineer, then they will eventually move it somehow. So from here the distribution happens, the distribution can happen into other teams. Of course, layout is one domain where they hire freshers also. Most of the times they will go with freshers also. So there are few domains where you see fresher hiring. So out of these domains, if I have to list down where the fresher hiring happens, one is functional verification, one is physical design, partly into DFT. These are the four domains where freshers are generally hired. Our statistics in the institute is a lot of hiring happens in functional verification. At least in last 4 to 5 months, 70% of our placements are into functional verification. So this is about ASIC design flow and the team distribution and what are the different roles in the ASIC. So I will spend another 10-15 minutes explaining you the training schedule. Now we'll go to the training schedule. By now I hope you understand what is the mean by functional verification, what does functional verification entail, all those basics. So now let's talk about the training schedule. First of all, let's talk about mode of training. Training is offered in three possible modes: full week training, weekends only training, weekdays evening training, evening batches. These two definitely happen. This only based on the minimum strength. If I have 1 or 2 people for evening batches, we don't do that. Okay. The majorly batches are available in full week and weekends only. This is meant for freshers who are available throughout the time. This is meant for working professionals. The full week training is offered in online mode, offline mode, and hybrid mode. Hybrid, you know, right? You can do part of the time online, part of the time offline. That complete flexibility you have. So before, when you enroll also, you don't need to tell. You can join as an offline student. Later for 1 month you can attend online. So that complete flexibility will be there. In this mode of training, you will get recorded video access for 2 weeks for every session. Let's say today, whatever session I'm doing, I'm recording. This video will be available for next at least 2 weeks. But not for entire course. We don't give that commitment. Reason why we don't do is people become negligent. I mean, if you know that something will be available for 6-7 months, you will never revise at all. You will never study at all. But if you know that today's session is only available for May 31st, you will surely revise it. Okay. That is the typical mentality, right? Weekends only training. Right now it is only available in online mode. But there will be, if those people who are working professional want offline doubt clarification, there will be a dedicated mentor at the institute. You can come down and clarify the doubt. But mode of training will be online only, weekends training. Uh, they will have access to all the recorded videos for entire course duration. Because they are attending only on weekends, so we are giving the videos for entire course duration so that they can watch any videos at any time. Now, weekday evening batches is only based on the minimum strength. If there are minimum number of students, then only we'll do the weekday evening batches. Irrespective of mode of training, every student will have a dedicated mentor for doubt clarification. Now, you could be online student, you could be offline student, you could be weekends only student. You will be connected with one mentor with whom you can get your doubts clarified. Of course, you have every day regular live sessions. Let's say today I'm having a session. You can always ask me the doubt. But in case you want to talk to someone as a one-to-one, you can still connect and get your doubts clarified. I told you that whatever name we use, they are all the same courses, right? Whether you use design verification, whether you use ASIC verification, whether you use functional verification, all are referring to the same course. I mean, even when we say the term functional verification, we also teach RTL design because that fundamentals are required in every case. Next. Let us talk about functional verification training. Functional verification training is for 8 months. It mostly goes to 8 months. Even though it's a 8 months course, your placement support starts from the 6th month of the training. You don't need to wait till 8 months to get a job. This 8 months will have 6 days of training per week, 4 to 5 hours per day. Typical timings will be 9:30 to 1:30 in the morning. Sometimes it can extend after lunch also. In this time, up to 1.5 to 2 hours of theory session. Remaining time will be the lab session. Lab session is mostly meant for supporting with the assignments. Means you will be given a lot of course assignments. To support you with those course assignment, we'll be having the lab session. So trainer will be sitting and he will be asking you to do the assignments, and wherever you are stuck, he will be supporting you. Every session recorded video access is for 2 weeks. I've told you, right? We have our e-learning platform in skill.in. where you get the login. If I take Verilog for example, as part of that itself, you will get access to the course presentations, the assignments, and the notes and the lab documents. So assignments presentation will be very detailed, and whatever presentation trainer uses, mostly the same presentation will be available here, which will be. Other than that, the project related presentation assignments are also quite detailed assignments. Okay, it is not like one line assignment where you do this. It will give you a detailed description of what to do. That kind of thing will be provided as part of the all these courses. So Verilog itself has almost around 20 plus assignments, close to 20 assignments. Similarly, for every course, there will be even whatever notes we maintain, that is also uploaded here, which you can access. Similarly, other courses, if I take system Verilog, the course presentation, the videos, the presentations will be available here. The assignments will be there. See, system Verilog will have around 15 assignments. Again, these assignments are also quite detailed, which explains step by step what to do, all those things. And you will also have the session notes and the labs. So, in summary, what I'm telling is Once you enroll for the course, you get one login where your respective course is added, where you get all the access. You don't have to get a separate documents for everything. Also, you get hard copy of the course material, the printed presentation and the notes, those things you also get it. All the course presentation, assignments and notes are available on the e-learning portal. Printed course material is provided for all modes of training. This 8 months training is divided into three phases. Uh, the question is why 8 months? Many institutes are doing 5 months. Sometimes institute finish in 4 months also, right? Uh, Reason is the general, the understanding level of the people who join the course in the institute is not very great. Okay, many times they lack lot of fundamentals. Okay? They lack lot of fundamentals. So because of that, they need that additional time to bring them up to a level where they can get a job. Because when you go to job, here in the training you are paying and getting the education. When you go to job, they will pay you and you will have to do the work. So the role is reversing there. So someone is paying you, they will expect you to do the productive work. You have to do the work, right? So for that you should come up, you should be at a point where you understand the problem, what is that work they want to give you, and you should be able to do that work. So it requires some time for people to come to that level. Even given an opportunity to me, given an option, I want to finish course in 5 months only. For no reason I want to extend to 8 months, right? It's unnecessary headache for me. I mean, instead of 5 months, doing 8 months is a unnecessary headache for me. In terms of the training rooms, in terms of the facilities, everything, it's a headache for me. The problem that happens when I do for 5 months is my training will be, it's not like I'm going to take break for 2 weeks. You will see that most of your classes will continuously be happening, except for festival breaks, except for some 2 3 days break between one major course and other. Let's say Verilog to system Verilog, we may give 2 3 days break. Other than that, course will be continuous almost. But still, it goes for that much time because we want to do it in depth. Okay. Again, reason is what? When there is one job, okay, it's not like only one person applies for it. There are almost 5 to 10 people who applies for this one job. So your resume has to stand out. Your knowledge and skill set has to stand out. Only then you get a job. So we want to do that. We want to make sure that we spend that time, additional time, and we want to make sure that you have that expertise to stand out from the other people. So coming back to the training is divided into three phases. Having said that, we don't want to delay your placements. The placement will start after this thing. You don't need to wait for entire 8 months. So training is divided into three parts. Phase 1 will be 3 months of training, phase 2 is 3 months, phase 3 is around 2 to 2.5 months. Phase 1 will cover advanced digital design, Verilog projects, and GWIM text editor. These are the things we cover in phase 1. Phase 2 we cover system Verilog and UV. We'll also cover Linux commands and soft skill training. Placement support starts after 5.5 months of the training. Then as soon as you complete this part of the things, your placement support will start. Phase 3 will be industry standard hands-on projects. Projects based on standard protocols like AXI, AHV, APB, Ethernet project. These all things will be covered. Other than that, we'll also teach Python scripting. We'll teach SOC flow basics. So this is the overall breakup of the entire flow. As a student, you have flexibility to do everything at a continuous stretch. You have flexibility where after this you take a 2 3 months break, then you start with this. Sometimes what happens is people are not able to cope up with the entire course. Then by the time we reach there, they still need a lot of time to gain expertise on system development. So we give flexibility to join this at a later batch. Let's say you completed phase 2 now. You can take 2 months break, you practice Verilog SVUVM properly, then you join the phase 3 after 2 months. That flexibility also will give. Okay. Phase 1 and phase 2 helps in getting job. I mean, interviews will be majorly focused on these things. Phase 3 helps you perform in the job. I mean, phase 3 is what? The project scripting association. These concepts are what is really you use in the job. So that will help you perform in the job. Almost all the institutes, all the other institute, their training starts after phase 2. I mean, if you see their course structure, they finish their training with this small project they do, which is not sufficient actually. If you do a small project, that won't be sufficient for you to get it. Uh, they do small projects which is not in line with the industry requirement. You won't understand the industry flow. Then you will have to go to the job. There you have to learn it, which is a problem because the company which hires you, they will feel not good about it. When you join a company, the company wants you to come prepared with the skill set. They don't want you to take you through the training. So many times that's the complaints companies have. The companies also give us their feedback, right? What do they tell is there are many times where they have to hire a person, then they have to take the person through again 3-4 months of training, internal training, which we are trying to avoid. We are trying to avoid that point because if they again have to take you through the training, this our training doesn't hold importance at all. So then at one point we become redundant. If the company again has to train, then there is no use of having a training institute, right? So we don't want to be in such a position. For experienced people also, only difference. I mean, many times people ask, what is the difference between fresher and experienced training? The difference is simple. In a fresher training, experienced training, this won't be there. Because the experienced person don't need to again learn digital design very long. They already know that. They will have all these things. Plus UVM advanced will be there. For an experienced person, first phase won't be there. This phase 2, phase 3, along with that some UVM advanced topics will be covered. That is so that is where the duration will be around 6.5 months, 6 to 6.5 months. Right? UVM main plus UVM advanced and rest of the things as same as previous one. So this is a brief about it. I mean, we can even go through FPGA, but I'm not sure how many of you are interested. So it will also have similar structure where we divide training into 3 phases: phase 1, phase 2, phase 3. The relevant topics will be covered in this. In all, we have planned the courses in such a way that you don't have to wait for 7-8 months to get a placement. If you are capable, you can get placement support after 5 months itself. Similar thing will be there for DFP as well and other courses as well. How to choose the right course? I mean, having understood the schedule of the training, uh, how it is done in every week. Okay. Now let's understand how do you choose the right course. I told you simple, right? You have to choose between front-end domain, back-end domain. Front-end domain requires bit of programming skill set. Okay. And then it requires debugging skill set. Then it requires ability to read the document specification and understand the specification. And what else it requires? It requires understanding of the standard protocols like AXI, AHP, uh, different protocols. You don't need to come prepared with anything. You may ask, I don't know any protocol. That's fine. You may say, I don't know Verilog. That's also fine. You may say, I don't know debugging. What is debugging? Also, I don't know. That is also fine. There are only 2 skill set that is required in every course. Any course you do, not only in this course, any institute you join, to get a job, there are only two things that anyone would expect: aptitude and attitude.
you should have a good aptitude. The quantitative aptitude should be good, very good. If your aptitude is poor, you will never get a job. Your aptitude is poor, whatever course you join any institute, you pay 5 lakhs, 4 lakhs, whatever you pay, you will never get a job. Because your aptitude, quantitative aptitude skill set defines how much you can comprehend a problem. Given a problem, how well you can understand the problem, how can you relate the things, right? It will tell you that. If you don't have that knowledge, that skill set, you will never get a job. Second is attitude is required, right attitude towards learning. Right attitude means what? Many things. The positive approach, ability to work hard, ability to keep motivated for throughout the course duration. That is all attitude. One term, attitude, summarizes everything. Means, are you willing to put effort for entire course duration? Can you stay motivated? Can you just focus only on the learning? Can you focus yourself on day-to-day work? Can you keep yourself uh, specific to the strict timelines? Every day I have to study for 4 5 hours, whatever happens. I have to finish these assignments. I have to make a notes. I have to revise the things. That is all what I'm calling as the learning attitude. Okay. If you have these two things, you get a job. Anywhere you miss, either you don't have right aptitude, right attitude, any of them, you will never get a job. Okay. Joining institute doesn't guarantee the job. Okay. Institute only plays a part of the role which gives you the right direction to preparation. That's all. That's all. Teaches you the right skill set and right direction. Rest of things are dependent on the student only. 70% is in the student hands only. 30% is what institute helps with, actually speaking. Okay. Now, coming back to the slides, how do you choose the right course? Choosing the right course is about knowing what is the skill set required for front end domain, what is the skill set required for back end domain. Okay. If you learn, choose front end, back end, any domain you gain expertise, eventually you get a job. Eventually you will get a job. Only thing is, what is my observation has been that in front end there is a better chance of getting a job. When you join course now, if you are good, there's a very good chance that within 6 7 months you have a job in front end domain. In back end domain, it can stretch to 9 months to 1 year also. You join today, chance of you getting a job can stretch to 9 months to 1 year. In front end domain, if you are good, a very good chance that by 6th month you have a job. At least that is my observation. Okay. Now it might change after some time, but as of today, more opportunities I see in the front end. Uh, okay. In summary, if you are good with programming skill set, go for functional verification. You don't like any programming at all, go for backend domain courses. Okay. One second. Okay. The third thing, middle one is the FPGA system design, where you need medium level of programming expertise and also expertise of working with the tools. Where you need some expertise with the tools, some expertise with the programming. There you go for FPGA design. If you don't want any programming at all, go for backend domain. Okay. If you are okay with programming, working in programming kind of domain, go for functional verification. But if you are strictly looking from a job, 100% job only, you can choose functional verification. But in any case, good quantitative aptitude, good right attitude is essential. Without that, you will not get a job. Whichever domain you choose. And if you ask me, I'll get into physical design. Can I manage without any aptitude? No. Because everywhere you need that skill set. You need to connect the things. In physical design, it's not like you tell tool will do everything. If tool only does everything, then you don't need there. If tool only does everything, you are not required there. So there is some thinking you need to do, and you need to apply that thinking. That comes only with right. Why I'm repeating so many times is, I mean, it's not like a disease that I repeat. I want you to understand the importance. I want you to understand the importance of what I'm telling. In an institute, let's say we have 100 students, if 50 people doesn't get a job, or 60 people doesn't get a job, it's because they lack in these two things. Either their initial aptitude when they join the course is very poor, they cannot learn the things at all. I mean, next level when I teach Verilog, next when I teach system Verilog, they cannot comprehend the things with very poor aptitude. If you don't have the aptitude, what happens? Initial 1 month you are serious with the course. Initial 2 months you are serious. After that you lose the focus. The people will travel around Bangalore. They will lose focus altogether. So that is where I said. I mean, people who get a job after the course, these two things were right. They have done it right. You don't need to really do any innovative things to get a job. No need to do any innovative things. Just be regular with your schedule. Other mistake people do is they don't revise it properly. It's like whatever you have done in the first month of training, let's say digital design. By seventh month, will you remember? You forget, right? So you go to interview after 7 months. They will ask you some digital design question. Can you tell that I forgot because it's done 6 months back? You cannot tell, right? You in the second month you learn very long. Again, will you remember in seventh month? Many times what mistake people do is they don't revise at all. They don't have a plan. Learning plan itself is missing. Means you need to have your own plan. See, I had my own learning plan, which is different from everyone else because I know my learning strengths and I know my weaknesses. So as per that, I had some plan, small plan, how to revise the things, how to keep practicing things. So that you need to have. So one of the reason again why people don't get job is because they don't revise at all. When you go to the seventh month, for digital design is entirely new again to you. It's like your first semester course or second semester course. Now it's completely new to you, right? You are in, let's say, eighth semester. For you, second semester course is completely new again, unless you keep revising it. What? Tell me, what do you think you should have done to make it easy? You should have made a notes. When you are in first and second semester, you should have made a notes of important points, which you can revise quickly. And you should have listed down some problems, which time to time you keep revising, you keep practicing, so that you keep that touch with the subject. Only then you will be able to quickly do. Otherwise, if you don't have that planning, what will happen? You will have to redo the entire book again. Read that entire book again. Let's assume you have done signal systems in second semester. Assume. Now in eighth semester, if you go back, for you, if you don't have any proper planning, proper notes, you have to read through the entire signal system book all over again. Rather, if you had made some important theorems and formulas, notes, everything, it would be just about revising those things and practice those things. In summary, getting job is all about these small things. Being regular, being motivated, and little bit of planning. You don't need to do any other innovation here. You don't need to invent anything at all. Okay. Course flexibility will be there. What is flexibility is, let's say today you decide to join front-end domain course, that is functional verification course. Up to 2 months, you have option to switch to other domain. No additional cost is charged. Beyond 2 months, additional cost will be there. You can still switch. There will be a cost for switching. You may say, what happens to the 2 months which I am missing? You don't miss 2 months. Initial 1 month is common for everyone. 1 month, this month, what you are attending, whether you are front and back end, it's all common. 1 month only you miss. That 1 month you actually join into the next batch. When you repeat, you join. When you join a new batch, you join into the batch that has completed only 1 month of time. That way you don't miss any topics. So what is the whole purpose is to keep it flexible, right? I mean, we don't want you to regret after 2 months saying that, oh, I decided and I don't like this domain. So we don't want that to be happening. Preparing for job, I told you, right? One, what is the difficult? I would not say difficult part. Actually, every learning will have its own difficulty. Without difficulty, if you get something, then there is no value for that job. Without any difficulty, if you get a job easily, that won't have any value. Okay. So you have to go through a difficult learning phase. I mean, you have to learn the things only then you are capable. But if at all I have to summarize, things move quickly here. I mean, lot of things are done in a shorter duration. Let's say entire digital design training gets covered in 3 to 4 weeks maximum. At a more depth than what you have done in your BTech. Okay. And in BTech you have one semester time to prepare the things. Here you have to prepare entire things in 3 to 4 weeks. And again, the most important thing is keep revising things. Let's say digital design is there. I tell this to every batch. Around 30-40% people follow that. 60-70% doesn't follow, and those 30-40% are the people who get the. Uh, so, what I was trying to tell in this slide is we do go deep into subject actually. I mean, Verilog also we teach almost for 8 to 9 weeks actually. Many places they finish in 4 weeks. Now tell me, given an option, what would I want to do? I want to finish it in 4 weeks. For me, it's good actually. Finishing the course is actually good for me. But the only problem is there are few things I'm worried about. One is you go with a half preparation out into the market. For your career won't be good. Okay, institute reputation will be spoiled because you are learning. Companies will also have a problem because they'll again have to teach some Verilog things. Let's say they feel that you didn't learn Verilog properly, they'll again have to teach Verilog. Okay, so that is the problem. Okay. Uh, Again, in summary, what is required for you to get a job? Planning, 6 hours of time. Let's say you take in a day, around 4 to 5 hours for whatever is happening right now. 1 to 2 hours for revising only. Every day, just keep revising some or other topic that happened in the previous months, because that is the only thing that is actually asked in the interview. When you go to interviews, they don't start with UVM, they don't start with project, they start with the fundamentals of digital design, which you studied in the first month. They will start with Verilog, which you studied in second month. They'll start with Verilog projects, which you studied in the third month. If you don't revise them and you go to interview, you will 100% miss the opportunity, right? If you don't revise and you go, you will miss the opportunity. You cannot justify that it happened in my second month, so I don't remember. That is the mistake every student does. Who don't get jobs, that is the mistake everyone does. So you have to little bit of planning on this. 1 hour I will spend for revision of topics. Only revision. I will not do anything that is happening now. I will revise only thing that happened in first, second, and third month. That planning, if you do, 100% you get a job. So people don't get jobs not because there are no opportunities. It's because companies don't find them suitable for the requirement. Let's say I interview, you don't know the basics also. How can the company hire? That is the situation where companies don't hire. We generally track the performance of a student. We place a student under a category of good, average, and poor performer. It is to provide that additional support. We not to tell you that you are a good batch student, bad batch good. Not like that. It is to decide how to provide that additional support. The performance tracking will be based on assignments, attendance, performance in the evaluation test, performance in the presentation. We will make you do presentations because at the end of training you should be able to present the things to the other person. Okay, how do you do in the mock interviews? And you will be having a dedicated WhatsApp group where you can get the required support. In that group, trainer will be there, admin will be there, you are there. So if you need technical support, trainer will provide. If you need some non-technical, administrative, some course related support, our admin will provide you that support. So what is the final goal of 8 months of training is, student should be enabled to work in the job independently. I told you, right? You are now, after this time, when you get into job, your mode is switching. Till this time, you are paying and getting the service. When you went to the college, you are paying to the college, they are teaching you. When you come here, you are paying, we are teaching you. When you go to the company, that role is getting reversed. What is getting reversed? They are paying you and asking you to do the work. So they will expect you to perform, right? They'll expect you to perform, simple. So that also they don't want you to do everything, like go to ask them what to do here, what to do here. Everything, if you ask them, will they feel good about it? No, right? They want you to do the job independently. Means what? Understand the problem, what you're supposed to do, come up with the process, then implement it. Okay. Our training is focused towards helping you reach that level. You are not at that level right now, because in your BTech mostly your exposure to theoretical learning means reading a formula, probably solving that formula, or remembering the theory, remembering some kind of text and reproducing. Here our training will be focused in such a way that your learning will be more focused towards the practical aspects of the work. So that will be the focus area. Okay. So with this, we let us stop the session. What are the course prerequisites? I told you, right? We should have a very good quantitative aptitude. Okay. Every batch I suggest, before you join the course, I suggest everyone to take quantitative aptitude test yourself. You can do self-assessment, right? You go to internet, just quantitative aptitude. Out of, let's say, 30 questions you attempt, you are able to score 15 or more, you join the course. Otherwise, you spend another 1 month, 2 months, you become very good with quantitative aptitude. Then you join the course. That 1-2 months is not going to impact. It's going to be very helpful for you. Okay. Why I am repeating? I mean, I'm repeating probably 10th time the same thing. It is so much important. Okay. Lot of times this decides the learning ability also. Then I told you, right? So you can take a test based on that. You spend that 1-2 months. Let it be VLSI course, let it be software course, let it be embedded course, or any course. You should do this before taking up the training. Because once you join the training, once you start with digital design, once you start with Verilog, you will not have time. It's okay to delay training for 1 or 2 months, gain that expertise, then join the course. Okay. Next. So what is that I want to show here in some of the testimonials is, many times what happens is, many students join other institutes, either because they feel the fee is very high, so the course must be good. Okay, sometimes those who charge high fee, you think that their course is better. They end up paying a lot of money, 1 lakh or more. Then they end up doing the courses with us, protocol courses, some advanced courses. They end up doing this, which anyway gets included in our regular course. Okay. So this is about. Now, if you have any questions, we'll discuss those questions. The placement, coming to the placements, only one thing I will tell is, if you complete 80% of the course assignment, which include the entire coursework, you take digital design, Verilog, system Verilog, the project. If you complete 80% of the course assignment, we will give you 100% job. If you complete 80% of the course assignment, I won't even ask any question. We'll give you 100% job. Now, if you ask me, there are in institute there are 50 people who don't jobs. They don't have jobs because they haven't done this. Okay. Now, what is this 80%? Why this number 80, 90%? What is this number is? Your confidence level actually. I mean that doing that 80% of course assignment gives you that confidence level that I am good with digital design, I am good with Verilog, I am good with system Verilog. You will reach a point where your confidence and your subject expertise will reach a point where you know that I can get it. Okay, because right now you don't know what is the industry expectation. So these assignments will prepare you for that, and you will reach a point where you are confident about your skill set. That time I can give you job easily because I want you to reach that level. So we will stop and we will go over any question and answers. Okay. Any questions you have? Those attending online, do you have any questions? Those in classroom, any questions are there?
Is it audible?
So if you don't have any questions, we will end this session here. Okay. So in case you want to enroll for the course is going to commence from Monday onwards. Monday and Tuesday will be some basic topics will be done. Okay.
Hello, sir. Hello.
Like the topics like Linux basics and GBIM basics will be done. Wednesday onwards, the
Hello,
digital
hello.
design will start. Why we are doing such way in that manner is sometimes people do
Hello.
join late, 1 or 2 days
Hello,
late.
hello, Reddy, sir.
If I
Are you
start
able to
with
hear me?
digital
Hello.
design from Monday itself, if they miss 2 3 days of topics, they miss that flow. They cannot. It will be difficult for them to follow. So rather, for those initial 2 or 3 days, we do the basic things, which are again repeated. Once the digital design is done, again we'll repeat Linux and GVim again. So that way, even if you late, you do, join late, you don't miss out the many things. Okay. Uh, yeah, Mega, right? What is your question?
Hello, sir. Hello.
You can please
Hello.
post the question in the chat window.
Hello.
Hello, is it audible?
Yes, you are.
Yeah,
Hi,
Mega
this
and
is
Priyanka,
Megha.
please post your question in the chat window. Anyone else having questions, please post your questions in the chat. Okay. First question is what? There is no need of programming for backend domain. Not much is required. Only PCL scripting is used, which requires a little bit of programming expertise. But to start with, you don't need any programming expertise. In summary, let's say even though you get into physical design, you cannot say that I don't want any programming at all. Little bit you should be willing to do. What is the your advice for people working in different domain for 8+ years now want to switch to VLS? Uh, Depends upon which domain you are working and the current salary. Let's say you're, for example, you're working in as a teacher, for example. Okay. College, engineering college lecturer. At 8 years, let's say you're 8+ years, you're getting 40,000 per month. Then it is suggested to switch that domain because that 40K at 8 years of experience is not sufficient to take care of things, right? So it is suggested to switch the domain to VLSI. Okay. Let's say you're already drawing a very good salary, let's say 2 lakhs per month, for example. It is a possibility, right? Then you should have a other motivation that I like VLSI domain. That's why I want to switch into the domain. I like the kind of work. So you need to decide based on that whether salary is the motivation, whether the kind of work is the motivation. Based on that, you can decide. Uh, but again, I need to see some of the other information, which domain you are working, which company you are currently working. Based on that, we can decide whether it is possible to switch. Okay. So which company do you work with, Mega? So why I am asking company is, if that company has any relevant VLSI domain, let's say she is working in HCL, Wipro, they also have VLSI domains. Then it becomes easy to switch the domain. I mean, you can always show that you have worked into relevant team. Then you can switch. But if it is completely software domain, software company, which doesn't have any VLSI division at all, hardware division at all, then it will be little difficult because you cannot justify it. For example, uh, I don't know which all few software companies are there. Uh, Even Capgemini has VLSI division. Okay, let's say there is a company called as Wells Fargo. One of the company I can think of. They only have software relevant work. They don't have any hardware division. Let's say you worked in Wells Fargo for 8 years. You cannot. It's very difficult to switch to VLSI because you cannot justify how did you do VLSI at Wells Fargo. But if you have worked into Capgemini, HCL, Wipro kind of companies where there is some small hardware division, you can always learn the things and switch. There are many people who have done that earlier. Course for offline. No, Kumar, what is your query regarding that?
Sir, course fee for online, offline, and e-learning, and there is any how the payment for like the duration, any installment kind of that. Those.
I don't understand the question. Course for offline, online, e-learning. Basically, the course is available in offline, online, and e-learning. Now you can, Kumar, you can ask a specific question, then I can answer. Next question is, what are the level of knowledge required for SOC project leader? SOC project leader should have the entire SOC design and verification flow exposure, verification flow, hands-on exposure. Now, if you want what specifically you need to know in design verification, you can go to our course page. Then there will be a syllabus. This entire thing you should develop. This is not for freshers. As a fresher, please ignore. You should know what are the different chip stages. I mean, what is meant by base tapeout, what is meant by metal tapeout, what is ECU update. Okay. Then you should have design concepts. In this entire flow, you should be able to understand how it is done in the project flow. This expertise you need. When will be the new batch started? During this time where a lot of students pass out of the college, the batch will start once every 5 weeks. Batch will start once every 5 weeks. Okay. Uh, the current batch is now it's starting, right? Next batch should be 18 plus 4, 22nd June will be the next batch. So next batch will be 22nd June, next batch should be 25th, 27th July. Accordingly. Uh, on what basis reference model will be developed by the verification engineer? Uh, I'll keep it very brief. So the reference model he's talking about, I told you right, during verification, we have a design model, we have a reference model. I said that you apply input, same input is applied. He's asking how this reference model will be developed. Reference model will be developed based on the reading of a specification. There will be a design document. By reading the design document, design engineer develops this one, the verification engineer develops this one. So the input will be the design specification will be the input for that. Any other questions you have? course fee for online, offline, online e-learning, how many installments can be payments be done. Course fee, you please connect with our admin team, they will help you. Installments, you can pay up to 3 installments. Whatever is the fee, depending upon which course you take. Generally, e-learning will be little cheaper compared to the offline and online courses. Now, regarding the installments, 3 installments, they will give you the breakup of the installments. So, better I would suggest you to connect with our admin and get the required details regarding this. As you said, UVM is like Java, but we don't have a knowledge of Java. Then will it be difficult for us? So what is that I said? You remember, right? I said you don't need to come with any expertise at all. Let's say you are joining into functional verification. Even if you don't know C language, even if you don't know the basics of Verilog language, that is also fine. Even if you don't know the digital design De Morgan theorem or what is truth table, that is also fine. But you should have that willingness to learn. That's all we are asking for. Because our teaching will start from the very fundamentals only. Our teaching will start from the very fundamentals of the digital design, very fundamentals of the Verilog. So I don't expect that you should be good with Java. I don't expect that you should be good with C++. I just gave an analogy. UVM is like Java. I'm not telling that come prepared with Java. Any questions? Okay. So if you don't have any questions, we will end the session here. Okay. Uh, okay, fine. Thank you, everyone.